We're going to look at the trig relationships defined for right triangles. The sine of angle A equals the opposite over the hypotenuse. When we say opposite, we mean the leg across from angle A. The cosine of angle A is defined to be the adjacent over the hypotenuse. The adjacent means the leg that is connected to angle A. And then the tangent for angle A is defined to be the side opposite of angle A over the side adjacent or connected to angle A. A shortcut way to help you remember this is to remember the little phrase SOHCAHTOA. So the S stands for sine, the O stands for opposite, the H stands for hypotenuse. In the CA, C stands for cosine, A stands for adjacent, H stands for hypotenuse. And in TOA, T stands for tangent, O stands for opposite, A stands for adjacent. In looking at example 2, we are asked to find the sine of angle A, the cosine of angle A, and the tangent of angle A. So all of these trig functions that we are finding are very specifically related to angle A. So when we want to find the sine of angle A, remember that the relationship for sine is opposite over hypotenuse. The side across from angle A is the 8. The hypotenuse is the 17. So the sine of angle A is 8 over 17. Now let's look at the cosine for angle A. What we are looking for is the leg that is connected to angle A. Here's the leg that is connected to angle A. That's the adjacent. So there's 15 over the hypotenuse is 17. Now for the tangent of angle A, you want to do the opposite, the side across, over the adjacent, the side connected to it, so you get 8 over 15. On example 3, we are asked to find tangent of theta for the figure we are shown. So everything that we are doing for tangent is in relationship to the angle that's over here. Tangent is opposite over adjacent. The opposite currently has no value. We have to figure out what that value is. So in order to do that, we need to do the Pythagorean theorem. So 8 squared plus what we don't know squared has to equal 9 squared. 64 plus x squared has to equal 81. Subtract 64 on both sides, you get x squared equals 17. So x technically is plus or minus the square root of 17, but the side of a triangle has to be positive. So the side that we don't know is the square root of 17. Now that we know the side across from angle theta, we can do the tangent for theta, which is the opposite, the square root of 17, over the adjacent, the leg connected to theta, is the 8. On example 4, we are given a figure and asked to find the sine for angle theta, the cosine for angle theta, and the tangent for angle theta. We are told to use exact values. So that means if we have a square root, we leave it in square root form. Looking at this triangle, we do not know one of the sides. if we are going to find the sine, the cosine, and the tangent, we need to find all three sides. So we are going to set up the Pythagorean theorem, x squared plus 7 squared equals 10 squared. X squared plus 49 equals 100. X squared has to equal 51, so x must be the square root of 51. So the side that we don't know then is the square root of 51. Now the trig functions that we are finding are all in relationship to theta, angle theta. So if we are doing the sine for angle theta, we want the side across from it, the opposite, 7, over the hypotenuse, which is 10. For the cosine, we want the adjacent, the leg connected to angle theta, which is the square root of 51, over the hypotenuse, which is 10. For the tangent, we want the opposite, which was the 7, over the adjacent, which is the square root of 51. You may leave it in that form, or you may rationalize it and write it as 7 square root of 51 over 51. On example 5, the directions say to solve for x in the triangle and to round your answer to the 10th. You will be given a figure, and in these problems, they will give you an angle measure and they will give you 2 of the sides. What you will have to determine is which trig function works for the information that you have. If I look at the angle that I have of the 69 degrees, and I look at the information that I have, I'm looking for x, which is the opposite, and the 19 that I have is the hypotenuse. Well, which function uses opposite and hypotenuse? The sine function. So what we are going to do is set up an equation that says that the sine of 69 equals opposite, which is the x we're looking for, over the hypotenuse, which we are told is 19. Now we need to solve this equation for x. Well, going back to our algebra, in order to solve for x, we would multiply both sides by 19. So x equals 19 times the sine of 69 degrees. Now you're going to put this into your calculator and round your answer to the 10th. If you put that in your calculator, you should get 17.7. This is the measure of a leg, and we don't know if it's inches, centimeters, yards. We have no idea, so we're not going to put a label on it at all. On the second figure in example 5, if we look at what we are given, we have our angle of 21 degrees. We are looking for the side across of it from it, the opposite, and we are given the side attached to it, which is the adjacent. If we have opposite and adjacent, then we need to use the tangent function. So we are going to set up an equation that says that the tangent of 21 degrees equals the opposite x over the adjacent, which is 9. This one will solve just like the last one, so x will equal 9 times the tangent of 21. If you put that in your calculator and round to the 10th, you should get 3.5. Example 6 is a very similar idea to example 5, except this time you are going to find the angle measure instead of a side length. So look at what you are given and what ratio it creates. Our angle x has the information for us of the opposite over the adjacent. So the ratio that we want to set up is tangent. We don't know the angle, so what we're going to do is say the tangent of x equals opposite 13 over the adjacent, which is 20. So this time we have to find out what x equals. On your calculator, there is a key that has this on it, tangent with a -1 exponent. That's called the inverse tangent. This function finds the angle that has the given ratio. So what you are going to have to do on your calculator is do the tangent inverse of 13 over 20, and then this will tell you what the angle measure is. Your tangent inverse key is generally the second function, so you're going to use your second key, and then above the tangent, there's the tangent with the -1 exponent. So you're going to do second, hit the tangent inverse key, and then do 13 divided by 20. When you do that, you should get that x equals, when you round it, 33 degrees. For our second figure in this kind of problem, looking at the angle and the two pieces of information that we are given the side that's connected to it, so we know the adjacent, and the 14 is the hypotenuse. Which function uses adjacent and hypotenuse? That's cosine. So this time we will say the cosine of x equals 11 over 14. Again, you're going to have to use your inverse key, so x will equal the cosine inverse of 11 over 14. When you do that on your calculator and round to the 10th, you should get 38.2 degrees. When you are told to solve a right triangle, what that means is that you need to find all of the missing angles and any missing side lengths. For example 7, we are given a right triangle that we need to solve. Remember, if you have a right triangle, the right angle automatically takes up 90 degrees of the 180 degrees that are the measures of the three angles in a triangle. So that means that the other two angles have to add up to be 90 degrees. If we know that one of the angles is 47, then angle B must be 90 minus 47, which is 43 degrees. Now we need to find side B and side C. When you are solving a right triangle, if at all possible, I recommend that you use your given information. What if we had made a subtraction error finding angle B, and we used that number to find the rest of our sides? Well, now everything's going to be wrong because our first answer was wrong. So I'm going to use everything based off of the 47 degrees that I was given. If I want to find side B, and I look at the information that I am given the side across from the 47. I'm looking for side B, so here is opposite, here is adjacent, and the angle is 47. So that means I need to use tangent. So we would say that the tangent of 47 equals the opposite of 23 over the adjacent which is B that we are looking for. So now we've got to fall back into our algebra and find what side B equals. So the first thing that we are going to do is multiply both sides by B. Now we have B times the tangent of 47 equals 23. Now to get B by itself, we're going to divide both sides by the tangent of 47. So side B has to equal 23 divided by the tangent of 47. Do that on your calculator and round to the 10th, and you should get 21.4. So now we know angle B, we know side B, we still don't know side C. So let's go back and compare what we are given with side C. Here's my angles, 47. I know opposite, and I know C is the hypotenuse. Well, opposite in a hypotenuse is the sine function. So this time, we are going to do the sine of 47 equals the opposite of 23 over the hypotenuse, which is C. This is going to solve just like what we did for tangent. We have to multiply both sides by C. So we have C times the sine of 47 equals 23. We've got to divide by the sine of 47 on both sides. So we get C equals 23 divided by the sine of 47. Doing that on your calculator, you should get 31.4. Why do we even need to know how to solve right triangles? There are actually many applications that use the concept of solving right triangles. We are going to look at just one of them, and these are called angles of elevation or depression. An angle of elevation is the angle that occurs when the line of sight is above the horizontal. An angle of depression is the angle that occurs when the line of sight is below the horizontal. So it's really important to recognize that both of these are in relationship to the horizontal. On example 8, we are told that we have a 14-foot ladder that's leaning against the side of a house. The top of the ladder is 12 feet off the ground, and we are asked to find X, the angle of elevation of the ladder. And we are also asked to round the answer to the 10th. Pay attention to what you are asked to round to, because you will be marked wrong if you round incorrectly. First of all, I want you to note that here's the horizontal, and the angle of elevation is what's coming up from the horizontal. So that's what we mean about the above the horizontal. So in looking at this figure, I want to find angle X. And the items that I have in relationship to angle X are the opposite and the hypotenuse. What trig function does that require? That requires the sine. So we are going to set up a relationship where the sine of angle X, the thing that we are looking for, has to equal 12 over 14. Anytime you are looking for the angle, you have to use the inverse function. So we are going to do the sine inverse of 12 over 14 has to equal X. If you do this on your calculator, you will get x equals 59.997, and that keeps going. We were told to round to the 10th. Well, because we have 9, 9, and 7, this is going to round everything up, and it's going to become 60. And since what we found was the angle, that is 60 degrees. In example 9, we are asked to find x, which is the angle of depression from the top of a lighthouse that is 165 feet above the water line of a ship that is 941 feet offshore. And again, we are to round to the 10th. So I want you to see here that the angle of depression, here's the horizontal, and the angle we are talking about is below the horizontal. That's why it is the angle of depression. So going back to our problem here, when we look at what pieces we have, the 165 is across from the x, so it is opposite, and the 941 is connected to the x, so it is adjacent. So if we're using opposite and adjacent, then we must be doing tangent. So we would say that the tangent of angle x has to equal opposite 165 over the adjacent 941. Again, we're finding the angle, so we're going to have to do the inverse tangent of our relationship of 165 over 941 will give us the angle. And when you put that into your calculator, this one comes out a little bit easier to read. You get 9.9 degrees. On example 10, we are told that an airplane is flying above the ocean with an altimeter indicating an altitude of 10,000 feet above the ocean. The altimeter is the instrument in an airplane that tells them how high they are. The pilot observes that the angle of depression to a ship is 20 degrees. What is the horizontal distance from the ship to a spot directly below the airplane? So on this problem, I have not given you a picture. We're going to construct a picture to help us figure out what's going on here. So first of all, we are flying above the ocean. So here's my ocean. And I've got an airplane flying up here. You do not get to laugh at my artwork. And we know that the altitude of that airplane is 10,000 feet. So we know that the distance from the ocean up to the airplane is 10,000. We are told that the angle of depression to a ship, so we need a ship out here. So out here we have our ship floating in the ocean. There's my boat. And we are told that the angle of depression to this boat is 20 degrees. So that means from the horizontal, so if I went straight out horizontally and then went down to the boat, that the measure between the horizontal and the downward line is the 20 degrees. We are being asked to find the horizontal distance from the ship to directly below the airplane. So we are being asked to find this distance. You have to be careful on this because the angle of 20 degrees is outside of our triangle. But we know that if we had a vertical of 10,000 and a horizontal coming out from the airplane, that a vertical and a horizontal are going to create a right angle. So if the outside angle is 20 degrees, then the inside angle must be 70 degrees. So now we're going to ignore this for right now, and we're going to look within this triangle, what relationship do we have? So here's what we're looking for. X is what we're looking for. The angle that we have is across from X. So X is our opposite. And the 10,000 is connected to our angle. So that is the adjacent. Well, that means we need to do tangent. So the tangent of the 70-degree angle has to be the opposite, which is the X we're looking for, over the adjacent, which is 10,000. How do I solve this little equation? Multiply both sides by 10,000. So X equals 10,000 times the tangent of 70 degrees, which equals, if you put this into your calculator, 2747.5. And since our altimeter reading was in feet, this is also in feet.